Hey, it's Zara, and in this video, I'm going to explain the difference between regression and classification in machine learning, and I'm going to do this using a very simple example. And if you are not familiar with machine learning, regression and classification are two fundamental types of supervised learning tasks. And by the end of this video, you will learn the objectives of these two models and what they are used for. To illustrate what each of these tasks can be used for, let's look at a very simple example of trying to classify this cat here. What could we infer about the cat? Well, the very first thing we could see is that, is this actually a cat? Or you could also attempt to determine what breed the cat is. You can infer the breed based on several different features, such as the type of fur it has, the size of its ears, and so on. You might also want to infer if this is a dangerous cat. Is it going to scratch you? Is it not going to scratch you? And you can also try to see if you can infer the age of the cat. Maybe if you know cats very well, you can tell what age the cat is, or you can start to count the number of teeth it has. Now, for all of these quantities, you can roughly categorize them into two different classes. One is regression values and the other is classification values. For classification, we could ask, is this a cat? What kind of fur does it have? And how many teeth does it have? And for regression, we could ask, how old is this cat? For the age, we can look at how tall the cat is and so on. The distinction I made here between quantities that we classify and quantities that we regress is that quantities that we classify are quantities that have very distinct classes that we assign to them. Another one would, for example, be the cat breed. Here, the class might not be that distinctive. It's not a purebred cat, but for purebred cats, it could either be a Persian cat or some sort of short-haired cat, or if it has no fur, then it might be a Sphinx cat or some other breed. And so these are very distinct classes. You can answer the question, what type of fur does it have, with three possible answers. It's either short, it's either long, or it either doesn't have any. The same for, is this a cat? It can either be a cat or it is not a cat. And the same for number of teeth. Unless your cat has lost part of a tooth, it's going to have a very distinct number of teeth, and it's not going to vary smoothly. However, with age or height, these are quantities that do vary smoothly. This means that if you are in these quantities and if you're off by just a little bit, your estimation is probably still fine. For example, if you think that your cat is 6 years and 9 months old, but it's actually only 6 years and 7 months old, it's not going to be a big issue. So regression quantities are something that we estimate and something that we want to get close to, while classification quantities are very distinct classes that we have to distinguish between. With regression, we often predict a real valued output, meaning that the cat's age belongs to a real positive number. The order and distance between these values really matters. For example, in regression, you can say that the cat is a little bit taller or a little bit shorter. You cannot say, for example, if you look at classification quantities, you cannot say that the cat is a little bit more of a cat or a little bit less of a cat. So for regression quantities, the order and distance between the quantities matters, and oftentimes the objective of regression is just to get close enough to the actual true values, and if you are slightly off, it really doesn't matter. Now for classification, things are a bit different. In classification, we're going to predict a specific class. It is oftentimes done by predicting an integer, and each integer corresponds to a separate class. For example, that integer can either be a 0 or a 1 in the case of gender of the cat if it's a male or a female. Or it can also have multiple classes in the case of the breed of the cat, where you could classify the cat into maybe hundreds or even thousands of possible different cat breeds. And the objective here is to guess the right class in absolute terms. It doesn't matter if you get close to the right class. Oftentimes, in classification, there is no meaning of what it means to be close to the actual result. You just want to get the actual result right. So that's all for this video. I hope this simple example was easy enough for you to follow and understand the difference between classification and regression.